Hello, I'm Darson. I'm Jonathan. This is our project, the Centroid Tracking for Robotic Arm. As you can see here, we have a little 3D printed stand. We have the OV7670 camera module, as well as two motors and a little stick thing, I guess. And what this does is that it detects the centroid on this MacBook over here, and the motors will automatically spin to it and point this tip at the centroid. And I'll have Jonathan explain how the camera module works.
So basically, the OV7670 camera takes a picture. We do a centroid calculation based on the color of the pixels using a threshold for white and black pixels, and we do a weighted average in order to get the centroid of the ball on the screen. So that information gets sent through the motors, and I'll let Darsan explain that.
Yeah, so for the motors, we're using an L298N motor driver. It sends the signals to these two motors over here, and it's powered with 5 volts from the STM32 board. How it works is that it takes the current centroid position, and it compares it with the previous centroid position, and it finds a dx and a dy value. And after it finds that dx and dy value, it uses the PWM to determine the speed. We have a function that maps certain dx values to certain speeds and certain dy values to certain speeds. And so the faster that you drag your mouse across this screen here, the faster the motors will turn, and the slower it will turn. And yeah, and we also have this MacBook here will be running a web app, which I'll have Jonathan.
So we can go through the demo. So we have a web app over here, which basically connects to a Python server that whenever a key is pressed over in the computer, information is sent through the UART in order to calibrate the motor before using the actual centroid detection. So let's go through that. So if the motor was not in the correct location, we can use the WASD keys to center it. And once we're happy, we can press the Q key, which sets a sequence which clears out the buffers just in case to prevent any bad movements. And at the same time, we have over here information of the actual detection of the motor, of the center of the ball. So we can see it here with the motor and at the computer at the same time. So let's move it to the right. So you can see it move to the right, then to the left, to the center. We can move up, we can move down, down, up. So yeah, and as you can see over here, it also moved to reflect the same location that was detected.
Yeah, that's it.
Thank you.
Thank you.